So right now we're just finding all the ratios by taking the current height divided by the previous height. Okay, you guys are going to fill out the rest of the table. We do need each ratio. So if you don't have a calculator, turn and talk to somebody near you. And then we'll start answering questions about our data, our graph. If you had to guess, what do you think the multiplier is? About half? Yeah, 0.5. Let's start answering the questions. Number 2. Does the data seem to follow a linear or exponential pattern? Exponential. Yeah, it's going to be exponential decay. Exponential decay. So we'll answer that question. Exponential decay. To explain why we have decreasing, a decreasing pattern, and it's curved. We've got a curve here. Number 3 says draw a sketch of the function that best fits the data. I saw a lot of you already did that. You sketched in the curve. That's fantastic. We want to write an equation for this. Okay, and we're going to use y equals a times b to the x again. A says, what's the y-intercept of this function? 0, 100. 0, 100. And we're still explaining the meaning of this in context. What does the 100 mean when I'm talking about a ball dropping?
The point of where they started.
Yeah. The drop height. Yeah, this is going to be the drop height of the ball. That's where we start. Part B says for the average, find the average of the 6 ratios. Do we know how to find an average? Yeah? Yeah, we're going to add them up and divide by 6. So we're going to add all these up and divide by 6. Will you do that in your calculators right now? I'm going to write out the work. This is what we're doing. We're adding up all the ratios, then dividing by 6 because we have 6 of them. This is going to help us find our multiplier. On average, what's the multiplier going to be?
0.67.
Uh-oh. I'm hearing lots of different numbers. Once you add them all up, divide by 6.
0.56.
Let's see. Everyone's calculating. Let's make sure we're getting the same number. We're going to add those all up and divide by 6. Let's give people a second. 0.56. Are we getting something closer to 0.5 now? That was our estimate. 0.56. Okay. Right, you guys said that maybe this is going to be half or 0.5, and that's what we're getting from the data. Okay, so now we're going to put it together. We're going to write the function. We're going to use h of b, and again, b means bounces. What's our starting value? 100 times, what's the multiplier? 0.56, and we're going to use the power of b. B is the number of bounces. Okay? Number 4, we're going to use the equation now. Predict the height of the ball after 10 bounces. So where do I put 10 in? For B, yeah, 100 times 0.56 to the power of 10. Let's see, what's your prediction? Point 0.3 centimeters. Any questions about this application of decay? Yesterday we did an application of growth. We did money. Let's flip the page. Let's look at our quick notes. Okay, so yesterday 5.3 was money. Today was an example of decay and writing an exponential model. Okay. Writing the equation from data or maybe a scenario. Always start by identifying the y-intercept. which again is our A value in the equation. The second step, you might have to calculate or find the B value. In our example, we were dealing with data, and we found the ratios, and then we found the average of that, okay? But if I just have a table, we're going to divide the second Y value by the first Y value, okay? Typically, that's how we're going to figure it out. And we always have to go back to our B value. Our B value. If it's greater than 1, it's going to be growing. If it's less than 1, it's going to be decay. So before, for the racquetball bounce, if we had gotten a B value greater than 1, we should have been thinking something's wrong, because this is going down. The height is not increasing. Okay. In the check for understanding right now, we're going to practice finding it from a table, finding it from a word problem. Does anyone need more time with the quick notes? Any ideas?
Oh, you subtract 295 from 230.
That sounds very linear. It's a good idea, but that's for linear.
Divided by 2.
Divided by 2. We're close.
When you divide it by 2, you get the percentage, and then you would divide that by 230.
I'm hearing some good things. Let's try it. Let's try it. Do we know our A value? Yes, we know our A value. It's 230. But I'm having a hard time finding the B value. Do I know another point?
Yes.
Okay? Watch carefully. We're not just going to round. We're going to solve for it algebraically. I do know this point. I'm going to replace 295 for Y. I'm going to replace X with 2. I plugged in the point. Now the only variable left to solve for is B. How would you solve for B?
You would divide each side by 230.
Divide each side by 230. Let's do that.
And then put that in
What's it called? You're right. What's it called?
like this thing.
This thingy. What's it called? Help him. Square root. Yeah. 295 divided by 230. 1.28 is B squared. And then, yeah, we're going to use our square root. So what is B? 1.13. Now we can write the equation. Y equals 230 times 1.13 to the power of X. So if you have the A value, that's great. If you have another point, you can solve by undoing. We did this last unit. Solve by undoing. Now let's use the equation. I'll give you a minute. Use the equation with your group for part C. Let's do the word problem now. Word problem. Read it with your group. Read it with your group. What points do you have? Read it with your group. It's going to double every 21 months. Let's figure out how many times it's going to double. Okay? We have the average internet speed. We'll use that as our starting value. That's our A. We're doubling. What's our multiplier then? 2. Not squared. 2 times 2 to the power of 3. We want to figure out in 63 months, what's the internet speed? questions?
No, I was reading math for the answer.
Oh, what do you got?
342.88.
342.88 megabytes per second. That's some fast internet. For the equation, the speed equals 42.86 times 2. But what's going to be different about this exponent? It doubles every 21 months. How does that change my exponent? What did I do to time before? What should I do in the exponent? Times it by 2? No. What did I do up here? Divide. So I'm going to take my months and divide by 21 to figure out how many doubles I have in that time period.